Good day, sir. Today I am going to demonstrate our proposed system titled Food Ordering Real-Time Inventory Management System. Today I will walk you through the structural architecture, relational database design, and then the core source codes and a live demonstration of our system capabilities. First, let's look at our project's folder structure. The system is intentionally built following the coupled architecture, separating our presentation layer for our backend microservice. Then as we can see here inside the admin folder directory, we have our client-facing presentation layout managed by index.html, and then admin style.css alongside our client side controller logic, which is the admin app.js. Moving to our backend API directory, the system utilizes a modular service structure. Then as we can see here in the folder API, then config, we see the database.php, which handle persistent object connection to our database layer via standard PHP data object. Under our core operational workspace directory, inside the API folder, then the food folder, we see we have read_all.php. This is to handle dynamic asynchronous data retrieval for our interface grids. Then we have create PHP to safely track newly added menu stack, and create order PHP to process transaction operation. Then next, we examine our relational database schema design, which enforces data integrity, explicit primary keys, and strict relational isolation across entities. Our food table encapsulates our system menu items like this. Food ID as our primary key, and then category ID is to establish item groups. Then food name, price, and stock to track active physical inventory counters. Our order table handles our transactional point of sale logging, tracking order ID as an auto-incrementing primary key. Customer ID to maintain client ownership, total amount for the financial checkout calculation, and order status initialized with a pending default initialize default value of pending. Then now let's examine the actual source code driving our core data transaction pathways. Communication between our admin layout and our database is handled asynchronously using decoupled JSON payloads. In admin app.gh, we see our global operational handler function window place test order. Then when an action button is triggered, this routine extract raw properties, packages them into a single structured object body containing a customer identifier and an item list array, and post this data array securely across the network to our endpoint container. Looking at our backend engine file, which is the create order PHP. The system initialize database level atomic transaction using DB begin transaction. This ensures strong data persistent. The script records a fresh tracking entry into our order date table immediately, computes an inner execution loop that updates our food inventory counts using an update query constraint, and finalize the operation using db commit open and close column. If a runtime failure occurs mid-execution, the system triggers a rollback sequence to completely protect our database record from state data corruption. And now, to conclude this presentation, I will demonstrate our live system functionalities and automated workflow in a real time. Please observe our active current live food menu. Our active current live food menu stock table grid on the right. Our API has successfully read our records, displaying cheeseburger with a live accurate inventory level of exactly 48 units. Now watch closely as I demonstrate the seamless integration between our transaction pipeline and inventory system. I will simulate an automated customer checkout by clicking the green button, which is the buy one button on the screen. An alert pop-up box will appear saying order generated successfully, ID number 4. Upon trigger engagement, our interface receives an immediate validation handshake response from our backend execution route showing success. I will click OK. To the moment our transaction confirms, look closely at our management interface update. First, our cheeseburgers available inventory stock as instantly and dynamically decremented from 48 units to 47 units, proving real-time inventory deduction capabilities on a screen. Second, our incoming customer queue tracker at the bottom is automatically appended as fresh interactive tracking entry for order ID, and this assigned directly to our customer with a distinct visual badge marking its current progress status as pending. To show the final validation of our data persistent, let's verify our database storage system directory. As you can see, refreshing our database table shows that our physical table records have updated instantly. Our cheeseburger stock is confirmed at 47 units, and our order log records our new transactional row perfectly. This demonstrates absolute data synchronization across our entire application system. This concludes the system capabilities and structural architecture demonstration for our research. Thank you very much, and if you have any questions, that just message us. Thank you so much, sir.